Hello world, greetings to everyone. I'm Anton Antonovich, a senior system engineer at Epam, and I'm thrilled to be a host for this exciting event. Today, together with Rolling Scopes, we are proud to introduce AWS All Stars events for user group 3CT. Our community is dedicated to bringing together AWS enthusiasts from across the region to share the knowledge, networking, and learn from each other. Today is a very special day for me personally. This is the first community event I have ever organized. And today we are streaming to a global online audience. Please paste in our chat where you're from. I know a lot of people from different countries today with us. Moreover, we have a very wide range of global participants. On the one hand, we have experienced professionals and experts for sure. On the other hand, newcomers, which just starting their AWS journey. And we decided to organize this event because we believe even one event can inspire you and change the direction of your career. And I'm a living proof. We are thrilled to have curated an incredible lineup of speakers to share experience with you today, and I'm deeply grateful for their time and expertise. Generally, sharing knowledge in the IT community is crucial for collaboration, innovation, personal and professional growth, community building, and advising the industry. By learning from each other, experiences and expertise, we can solve the problem more efficiently, develop new ideas, and build strong relationships and networks. Ultimately, sharing knowledge helps us to improve the IT industry as a whole, and I want to personally thank to our speakers for their effort of all global AWS community. Our speakers are true rock stars in our community, and I know we will all learn a great deal from them. This is an incredible opportunity for us to expand our knowledge, connect with others, and support an important tech community. So let's give our speakers a warm welcome and get started. Thank you for being here with us today, and please follow our social networks for the next great events. I hope not only online. So let's spend our time wisely, and let me introduce our first speaker for today. And our first speaker today will be Victor Wednich, who was my mentor during my learning in the Epam DevOps Academy. Victor, you have taught me so much and inspired my passion for DevOps. And now Victor is working at Amazon as a senior developer advocate. Victor is DevOps evangelist, speaker, system architect, trainer, and community builder. Also, he's the founder of DevOps Kitchen Talks channel and AWS podcast in Russian. Now Victor located in Munich, Germany, and his presentation about chaos engineering. Victor, very welcome, and please go ahead.
So many beautiful words about me. You prepared great intro. Thank you very much, Anton. And hello, everyone, to our first meetup. Hello, world in general. Like I expected, like a lot of people would be from Gdansk, but I see Uzbekistan, Ukraine, Georgia, Kyrgyzstan, Poland. Yeah, so it's really, really great. And yeah, I know that people under the hood. Can you please put my presentation? Just like, yes, thank you very much. That's really great. Yeah. As I know, I am developer advocate. Please don't ask me what this means, but almost more than 10 years, maybe around 12 years, I work as system engineer. It's like DevOps engineer. And I got a lot of experience about DevOps. For that reason, currently I can speak about house engineering and how we can apply it in our application, in your journey of your application. If you want to follow me, just like you can find me on Twitter, LinkedIn, you can write me to Telegram. As usual, I am really happy to hear your feedback. So I remember the time when I joined one of my first projects. to Epam, and it was in Epam. So one of the developer came to me and say, "Hey, Victor, let's do some small, tiny changes in production." So I fixed my bug. Let's deploy this application to production. It's not a big deal. It's not a problem. But as you can see, what is illustrated in this really great GIF, so it's felt everything, like it was cascading failure for the whole production. And it's very difficult to understand what's really happened. It's because we deploy these small, tiny changes, or it also was based on some, in other circumstances, really something happened and so on. And it's very, really difficult to understand when you have your microservice architecture. Sometimes you do some stuff with one microservice and it can really affect in another applications. And when we are living in the world when if your application is going down, you're losing your money, of course. Based on the research from Gartner, every minute of downtime, it costs a little bit more than $5,000. Of course, I understand, like if you have your startup application and you have only 2 users, yeah, it will not be cost $5,000 per minute, of course. But if you include it in virtual 1,000 company, 1 hour for you will be cost more than 1 million per hour. So this money is incredible. I mean, like it costs a lot of, and you should be prepared for that. But how we can prepare? We should prepare to our downtime. But what's exactly downtime means? Like, what's the phases we include in the downtime? Because sometimes people say we have a downtime, but what's exactly really happened? What's the phases of this downtime? And I want to a little bit explain what's the phases included, and I want to start from detection. And during today, just like during the whole of my presentation, you will hear a lot of time word monitoring. Guys, please use monitoring. Monitoring is the heart of house engineering, is the heart of your engineering of your application, because you should understand what's really happened. And the first phase of downtime is detection. And please don't be in a situation when your customer call to you and say, "We have a problem. Our application does not work. What's really happened?" And you figure out only after the call from the customer, or I don't know, like someone say for you that something happened with your application. Configure your monitoring. Make sure that you understand what's really happened with your application. Is it working fine or not? Please be aware. So this is when we understand, okay, we have a problem. Houston, we have a problem. The next phase is evaluation. Evaluation means like we go inside, reading the logs, for example, look at our metrics, maybe go to some trace and so on, just like understand what's really happened and why. Try to figure out the root cause, why this happened. What the circumstances was just like to bring to this situation. The next phase is response. It means like you understood what's really happened. That's fine. That's good. But you also should I hope I am not muted and you can hear me. I just like read the message from Vasil. We cool. Response. We are in the response phase. A response phase, like you prepared something for your bugs, like I don't know, like you like deliver some issue and so on, and you prepare this response. I mean, like you prepare some configuration changes, your manifest, Helm chart, and so on, or maybe you fixing some inside of your application and so on. Yeah, and you're ready to deploy these changes, and these changes can bring additional issues. So you don't want to be in situations that during the response you also bring some issue with bugs and some issues in your production. So here we run some additional tests, and we almost done. I mean, like when we are on the recovery phase. Recovery phase means like we deploy all the changes and we are ready that our application will be the final state, but it's not the final step of downtime. The final step is the confirmation from our customers, from our clients. And like when you see the same amount of the traffic, for example, the same amount of requests, you're on the safe place. If you don't see, it means like it's an issue with your bug fixing and so on. So be careful. Also understand like what's really happened. And all of these phases include a lot of stress. I remember when I work as a call engineer, it means like someone from support team can call me at any time, and at 3 a.m. I have to wake up and try and figure out what really happened and try to respond on this issue. It's really, really dangerous situation. And you can say like it's only related to distributed system, because distributed system is really hard. But if you look at any system currently what we have, and of course, like if you look at the Amazon or the Twitter or Netflix system, we will see a lot of dependency. It's after discard microservice architecture. Of course, in this situation, if I do some changes in one application, I can affect another one, and it can bring like cascaded failures. From another perspective, if you look at any application currently, like for example, client serial application, we will see a lot of steps for this communication. Just like client generate a message sends through the network deliver it to the server makes a response, sends the reply through the network deliver it to the client. And if you go through all of the steps, and it puts 6 steps only for this simple application. I mean, like simple client-server communication. And sometimes anything can be happened here. I can say, you would say like, okay, we should do only house engineering, apply some random changes and look at our system. No. First of all, what you should do is prepare your unit test, your functional test. You should understand how your system works correctly or not, like cover your business logic, cover known issues. Like, for example, if I send this request, I should get response from my databases, and I should include some content in this response. You should create testing for your application. But at the same time, how Werner Vogel said, it's our CTO. You can imagine like CTO of whole Amazon. So I'm working for AWS. AWS, it's a small part of Amazon. So Werner is a CTO of the whole Amazon, like including marketing, markets, and so on. Alexa, all of the company was included inside Amazon. So Werner said everything can be broken. And we as AWS also know about that. Try to prepare for all of the stuff. But how you can prepare? For example, you can have an issue, like you have load balancer and a lot of servers inside in your load balancers. And you send the traffic to one server, to another server, and so on. And some of the servers response, 500 error, and you don't understand what's really happened. And that happened because you have a lot of logs, and you have not configured your log policy, how much you want to save these logs. And without monitoring, it will be very difficult to identify that this server has an issue, because in this case, you can create some policy, for example, or go to inside and this server and just like delete these logs and back your system to the normal situation. So house engineering, mostly, it's a practice which helps us to understand what will happen when we do some stuff which we currently don't know. Like, for example, try to uncover hidden issues. For example, if I lost couple connections to some databases, if I lost connection to this service, or I disable some daemon on my Linux machine, and so on. What will be happened? House engineering try to answer this question. The main definition of house engineering is discipline. You should understand it's discipline of experimenting on your system to build confidence. I mean, like confidence is means like you understand what will happen if I do some stuff. And you should create, improvements of that you should really understand what's really happened with our application. House engineering, it's not like break some things like on this funny GIF, when guys have an issue with their wheel and try to fix this issue on production, just like during the moving on the road. No. House engineering, it's not about that. House engineering, it's a real practice. First of all, it's engineering practice. And when I speak about engineering practice, we mean like we have some approach, patterns, what we should do, like step number 1, step number 2, step number 3. And I want to cover with you like what we should do when we want to implement house engineering. First of all, as already mentioned, you should implement monitoring. It means like you need to understand what is your steady state of your application, what's your normal situation, like how many requests you can cover, what's your latency, throughput, load of CPU, all of the stuff. So you understand what currently happened with your application. You create your hypothesis, like what will happen if I do some stuff. Turn off this virtual machine, for example. You run this experiment. As soon as you run this experiment, you have documentation, like you write something, logs, for example, and verify that your hypothesis and what's exactly happened during this experiments, it's the same, or like you have some issues. And of course, as a final, it's improvement, because when I speak about like DevOps engineering, DevOps practice, mostly it's a circle. When we do some improvements, we do some experiments, and at the end, we should do some improvements of our system. So it's a phase of house engineering. But how to implement house engineering? Sometimes it sounds like really difficult. Why? Because we have to install some agents, write our own home script on Python or Bash, and so on and so on. And sometimes it can be really, really difficult to implement. For that reason, in AWS, we have a separate service, storage. Like currently, I'm going to speak about VoltEngine Simulator and show in the demo how it works, what we can do. But it's one of the possible way how you can implement, I want to show you the best practices, how you should start to implement house engineering practice in your project based on the fault injector simulator. So in fault injector simulator, we have easy start, real world condition, and safeguard. Let me a little bit explain deeper every of the stuff. Steps. The first one is easy to get started. When I say easy, it means like you can open your AWS management console and do some stuff like this. Let's create our experiments. Or another one, if you prefer to work with CLI, you can do it also. So when you generate your scenario, you can send the output in JSON and store it in your Git. And for every CI/CD steps, you can run this, house engineered experiment. Also, it can provide for you real-world conditions. I mean, like sometimes when we have an outage, it's because we have some separate events happen at the same time. I don't know, like we lost connection to databases, we lost connection to something else. We do just like a lot of different stuff, and this happened at the same time. So in fault injector simulator, you can do some experiments in parallel, in one by one, and so on and so on. And the final, it's safeguard. It means like you have a stop conditions. So you have a button when you just like say, stop, please stop this experiment because I affect my end user. House engineering is not affect your end users. House engineering is create confidence, like develop your confidence about the system. It has integration with CloudWatch, it's integration with Epam because we want to make sure that we are working only with some part of our application with specific resources. What the components include in fault injector simulator? It's action, target, experiments, and experiments template. In real world, like from architecture perspective, how it will be looks like. In the center, we have fault injector simulator. It's our, let's say, it's our console where we create some experiment, for example. It has connection to Epam. It means like we can granularly control what we can do and how we can do. We can start it from management console or create through the CLI. We run our experiment. Our experiment will affect maybe compute instances, databases, networking, storage, and also have integration with CloudWatch. Or, for example, if you already have your own monitoring solution, I know, like, for example, New Relic, maybe something else, you can integrate it with your third-party monitoring. But it should be integrated because monitoring is a central place of the whole house engineering. You should have really confident understanding that your system currently works correctly in the right way. Yeah, and in case something happened wrong, like we affect our end user, we stop, just like we don't see any requests, for example, and so on. We can stop our experiment. So, what we supported currently, like we can stop EC2 instance, we can emulate API throttling, kill process, latency injection, so on, so on, so on. A lot of different, like actions what we can do. But I believe you're a little bit worried about like slide deck and understanding what is house engineering. Let's do it in the practice. And before we jump into our demo, let me explain small scenario. What exactly I'm going to show for you. So we have our internal application. It's social app application where I type my name and a message. A message, I don't know, like what's the weather today in the Gdańsk, for example, or in Kyrgyzstan, or I don't know, in Belarus or in, I don't know, somewhere, doesn't matter. And this application is currently internal. I mean, like it works internally in our company. And CTO said we should prepare this application to publish outside to external user, but we don't have like 100% confident about how the system will apply if you apply some turbulence. What's our configuration? I mean, like what's the architecture of this application? We have super simple application. So it means like two-tier, like let's say we have some instances. It's our front end and back end at the same time, and we have our data layer, it's RDS. Also, we put everything to after-scaling group, but as you can see, we have only one instance. You ask me why. So my answer will be in this case, if you lost this instance, after scaling group will recreate it for you. So you a little bit safer in situation if you have one instance without after scaling group. Also, we have, of course, VPC and load balancer, which will spread this traffic if you want to scale and add more instances. And based on this architecture diagram, I decided, okay, I'm ready for experiment, and my experiment will be stop instance. My hypothesis, if I stop my only one instance, I will lose a connection to the whole application, just like I will get some error. So experiment design, I'm going to stop and start instance because after some period of time, I want to stop this instance and make sure that everything works correctly. And I was also in the situation when, like I stop and start application, and this application did not work correctly because during the restart process, we forgot to do some stuff. So our target is a single instance, and let's run this experiment. Currently, I am based in AWS console, open VoltEngine Simulator, and define the name of this experiment. Defines as it will be stop single instance. Also, I can define some optional name. Also, as you can see, I can select EAM role, and based on this EAM role, I 100% sure that's what I will affect. I mean, what kind of resources I can affect, and so on, so on. Also, in the action, of course, I am preferred to select currently to stop my instances. And so in name, I can define what is the name. And in action type, I can see the whole list, what currently supported by VoltEngine Simulator. And in our case, it will be pretty simple, because we want just to stop our single instance. And in the target, we will select our single instance, but a little bit later, I will show how we can, to define some part of our resources, what we have. Also, as you can see, I defined that I want to start this instance after some period of time. In my cases, it will be after 2 minutes. So in target, I can have currently only one instance. And if I switch to EC2, which is currently want to define the name, my resource type, it will be EC2 instances. And also, as you can see, target method, it's ID. You can see currently I have only one instance. Just to prove it, here we go. We have only one instance, which currently in the running state, it's the same ID. And we save this experiment. So we currently don't have any stop conditions. So it sounds like a little bit risky. But anyway, we want to create our first template, first experiment template. So let's run this experiment, and just under the hood, what will be really happen? Under the hood, we run some, a logic like Lambda functions trigger to do some stuff like stop this EC2 instance, waiting for 2 minutes, and then back online. So we currently initiating our experiment, and if we switch into EC2 instances, we will see. First of all, of course, let's check our application how it works. EC2 instances is in the stopping phase, and just in a couple of seconds, it stops. And currently, if I try to refresh my page of application, we will see, of course, 500 error, 503 temporary unavailable. So we based to the completed phase of this experiment, and it means I should to start my application again. I should start my EC2 instances. Let's double check. Yes, it looks like running. And we also can check what's the status of our application. I mean, to refresh again this super complex application. Looks good. We finish with our experiment, and once we can improve. I believe if you think about it, you say let's add additional instance. You will be absolutely right. But again, guys, I already mentioned you should have a monitoring, and monitoring will help you to make sure that you are not affected during your experiments, your customer, your end user. For that reason, first of all, what we should do, we should implement some monitoring and define our condition stop. I mean, when we should stop this experiment because we see that we started to affect our end user. And again, as you can see, I already created CloudWatch alarm. Again, I want to highlight that you can integrate with another monitoring solution. It's absolutely up to you what you prefer. I don't know, again, if you have New Relic or maybe some another monitoring system, you can do it, not a big problem. So we want to update our experiment. In this case, it will be absolutely the same. Yeah, the trigger is the same. Absolutely everything is the same. We still have only one instance. But in stop condition, we want to define that if this alarm will be in the array, something happened wrong, we should stop our experiments. We don't want to wait for this additional 2 minutes and run back our EC2 instance. So again, let's start our experiment. We made our changes at our stop condition and start our experiment. So again, initialize running, and if we currently switch to EC2 instances, first of all, switch to CloudWatch, we see that our event in alarm state is like a red state, and we stop our experiment. Why we stopped? Because we saw issue, like we saw alarm, and we stop this experiment, and we will not affect our end user. Of course, it will be some, like stop start the instances, we can lose some couple of requests, but anyway, it will much safer than we wait like 2 minutes and start again our EC2 instance. What we can improve in this scenario? Of course, we can add additional scaling, like we can add additional instances. And what's in this experiments we want to do? Just like we want to stop our only one instance from this after scaling group, and we should just like we can prove that we can continue serving our request from the clients, and this request will be successful. I mean, like not 500 something. So our experiment designed stop start against instances, but it will be only one instance from the whole after scaling group. It can be not one, it can be, I know, 2 of after scaling group, and so on, so on. So as you can see, I already scaled my application, and I have 3 instances in running state. In this time, I'm going to create a new experiment, stop one instance from the whole group, define some additional name, and of course, as usual, please don't forget that you have EAM role. Based on the EAM role, you can control granularly what you can affect. Like, for example, you don't want to affect RDS instances. You can say like only EC2, but not RDS. In action, again, it will be the same action because we want to stop start our instance. The biggest difference, it will be related to the target. Previously, I selected only one instance because I have only one instance based on the resource ID. In this time, I want to randomly, like housely, select one of the instance and stop it. So how I can do it? I can define some filter based on the resource tags, filters, and parameters. So based on the tags, what you should assign, please use the tags in your AWS account. It will really help you a lot of time because, for example, who spend for something or filter some applications or filter some resources, it really helps. So I define some tags, and also I want to affect instance which currently in running state. I don't want to stop instance which is currently already stopped. So and count. In the count, I can define like 1, 2, 3, depends how many instances you want to stop. So we create our experiment. Also, don't forget to select your stop condition. It's very, very important. Let's run our experiment. So as soon as I start my experiment based on our hypothesis, what we're going to do, just like select one of the instances which currently in the running state, and stop it. And also, if we refresh our application, just like to check connection to our application, it should work correctly. And also, our alarm will be in the green state. I mean, like it will not be in an alarm state. So one of the machines is going to stop. Our alarm is okay, looks good. Everything looks good. Let's check our application. Let's refresh, and let's type something. I mean, like some test message to our application. Should it works? It should works. Let's post it. It works. So we stopped our instance, and just like in 2 minutes, it also should start it back. I mean, like this instance which we stopped, we should start it back again. So we can continue for a long time with these experiments, like to do some random stuff. I mean, like let's do some experiments with RDS. Let's do some experiments with VPC, for example. For example, you can lose some couple of connections, or you cannot make some DNS resolutions. What will be in this case? You can continue with these workshops. So I'm really big fan of doing by your hands. I mean, like try to do by yourself, because when you listen and try, just like only listen, it means like you will not remember. But if you try it, I believe you can just like learn something new in your right way. But let's back to our presentation. What we can do some another fun stuff. So we can block the NAS. I already mentioned. We can fill up our disk, like lost all capacity in our disk. We can kill random process in our EC2 instance, or for example, detach our EBS volumes. Everything can be possible. Like you can do almost everything, or mess your etc host file. But just like to summarize, first of all, start from very small steps. Some of the clients came to me and say, we want to implement House Engineering. Should we turn the whole of our region, just like war availability zone? No, guys. Please start from very small steps, like select one EC2 instance, stop it, start it, make sure this experiment works as your hypothesis, and maybe implement in your CI/CD pipelines. Also, be very careful with your production. Minimize your blast radius. Blast radius, it means like how many resources do you affect, how many, like what's the results of these experiments will be. You not affect the whole production, just like stop everything and just broke and affect your customer. No, we remember the numbers from almost the first slides, $5,000 for 1 minute, and have emergency stop when you just like stop your experiment. It should be your monitoring solution. Monitoring is a central place of house engineering. And be careful with stateful, because during the stateful, if in stateless, like in our experiment, we lost couple connections, couple requests, it's not a big deal. But if you broke your database, it means like you can broke the whole system. Be careful with that. Don't corrupt your data. And again, I want to finish with this great, definition of what is house engineering. First of all, house engineering is not breaking things without purpose. House engineering, it's engineering practice. We remember, just like we have our state based on the monitoring, we prepare hypotheses, we run our experiment, we make some improvement, just like circle. It should be, like improvement something, and have control environment where you understand what's really happened with your application, and well-planned experiments, not try to write some Python script which will randomly, kill some process or detach EBS and just like without control of what exactly you are doing. It should be in a control environment. And you create confident understanding of what really happened with your application. Will you affect some another part, like microservice and so on. And as usual in AWS, we really happy if you just like share with us your feedback. There's a just like QR code on my session. If you just like scan it and leave some feedback about my session, maybe I should add more, like demo part, less theory, like or expand a little bit deeper. I know the implementation and so on. You can leave this QR code. We'll be really happy if you can just like type some words about the presentations. I'm done. Hello, Baku. Hello, Baku. Just like one message, Anton, one message before we continue. Guys from Azerbaijan, please write me. I really want to be in Baku and organize user group in Baku. That's it.
Thanks, Victor. Thanks a lot for this exciting presentation. In conclusion, we have one question for you from Armenia. Question is already on the screen. It is common to use tools like Chaos Monkey, and do you have experience to run it on production? If you're able to comment that, feel free.
Able to comment, guys? No, sorry. With Chaos Monkey, I didn't implement, so I understand. Just like if you're ready to implement house engineering, like your project, it's pretty mature. Like you went almost the whole process. Like CI/CD improvements and so on, and you're ready to implement something. I didn't realize house monkey in my project. Sorry, but I had a lot of positive feedbacks about that. You can do it, just like, but be careful again. With house monkey, you have to install and configure all of the stuff. Your agents should be installed in your EC2 instances, because if you want to stop some instance or kill some process or manage your network connection, like latencies report, it means like you need some additional agent. So be careful with that, because I remember the time that when we implemented one of the application and we have so many agents, just like agent for logging, agent for monitoring, agent for tracing, agent for something else, agent for security. So real production consumption of this server was like couple percentage, but more, like some additional agents. So be careful also with that. I think
Yeah,
that
thank you, Victor, for this comment. And guys, yeah, Victor will stay with us if you will have another question. If you want to ask something, please text in our chat and we will try to pick it up. Okay, in this case, let me pass the floor to the next speaker. It is Denis Astahov, AWS hero, solution architect at Ops Guru, mentor and owner of very famous YouTube channel ADVIT. Denis now is located in Vancouver, Canada, and his informative YouTube videos were catalyst for me. Attending my first DevOps event several years ago, and Denis' content has educated and motivated so many people in our community. Denis, you are very welcome, and thanks a lot for your time. The floor is yours. Feel free.
Thank you for introduction. Thanks for warm welcome. Happy to be here. And today we're going to talk about why you should use AWS organizations. Switch to my. All right. Just a few words about myself, what you already know. Solution architect at Ops Guru. I'm certified professional of public cloud provider. Amazon Web Services have 7 certifications. I think almost all of them already expired, by the way. Google Cloud Platform, and also one simple certification from Azure. I am AWS community hero, and I'm owner of YouTube channel ADVIT, where I publish tutorials. I have almost 500 tutorials in total, I think, in almost, so it's a lot. All right, anyway, let's switch to AWS organization. Some basic scenario: when you just open your account in AWS without any organization, basically default situation, you have your credit card, you open AWS account, usually it's called root or master account. Now it's called management accounts. Basically, it's many different names, but for the same. You just have one AWS account and start provision your infrastructure. So you provision your production infrastructure, also staging for sure, and development. Basically, everything in one account. But how you can control, and it will work, for the some basic stuff, it will work for sure. Why not? But how you can control cost per environment? For example, you want to control cost of the staging, how much staging costs you, how much development costs you, how much production costs you. So to get the numbers, it's a little bit hard to make it in one account. Also, how you control access to environment. For example, you don't want your developers access your production. You want them just access only dev EC2 instances and RDS, but they will see in EC2 console all of them. So it's a little bit tricky to control specific access, to specific resources in one account. Also, where you will store your security logs, for example, CloudTrail, in the same account in the S3 bucket. So what if somebody will compromise your account, like will hack your account? So they will have access to your production, to all your environment. They will have access to your security logs, to delete basically these logs, to eliminate fingerprints. So this is if you're using one account, but there is a solution to use a little bit more accounts. And you enable AWS organization. When you enable AWS organization in your, again, first account, when you just open it, you can create more accounts. So for example, you will create specific account for development, which will be completely isolated. You will create additional account for the staging, another account for production. What you optionally can do, you can not use it, but you can use it. You can create organization unit, it's just logic basically folder where you can place all those accounts, staging, development, production to this organization unit. For example, you will call this organization unit R&W, like research and development. Maybe you have additional accounts you can create, just depend on business case and just your requirements. So we will create for the manual QA, for the automation QA, specific dedicated accounts. You will create also again, it's optionally a organization unit for this QA accounts. And will you restore your logs and like your all security stuff? You can create additional account for the security. Basically, it will not run any servers. It will store only security logs, and it will store security logs from all of the rest of the accounts. So security logs, even from management, from all of this, will be stored only here. So the hacker, if he will come, he will need compromise probably few accounts. Like, so first to get some resources, to access some resources, and after it, he will need to access security. It's like to hack another additional account to delete some security stuff. It's much more tricky and much more harder to hack 2 accounts. And here you can place your servers. Development will go to the development account, staging will go to the staging, production to the stage into the production, And manual QA, yeah, probably will run some servers over there, dedicated servers for the manual QA, dedicated servers for the QA. And security, as I told you, will put S3 buckets for all your security logs, for, let's say, guard duty findings, for CloudTrail for sure, and REST, for the AWS config, compliance, non-compliance, basically all the logs, everything what is dedicated to the security, you will put on this account, and it will be forwarded from all of the rest of the accounts. Basically, it's a centralized place for the security logs. All right. What type of the accounts you have when you enable organization? First, yeah, it's for sure, it's management, root, master account, whatever you call it. Basically, it's main account where you attach your credit card. And in the organization, what is nice, you don't, this account will continue pay for the management account, for the main account, and also it will start paying for the rest of the account within organization. So when you open new accounts, you don't need to pay, like attach your credit card or separate, attach different credit card to them. You just use your credit card in the master account. That's all. You just open an account. It automatically adding these accounts into the billing. In billing, like on one of my latest slide, you will see how nicely you can see how much costs you a specific account. And there is a second type of the accounts called members account. It's basically not everything what is not root, everything. And members account can be from two statuses: a joint account. It's external account which is invited to join the organization. For example, you have two management account. Like you open one account, attach credit card. You open completely another account. You attach it with attach the same credit card, or maybe use another credit card. And later you decide, well, I will create one organization. I just want to, put everything under one pay billing, basically. So the second account which you have, you can join, like you can invite it to join the organization. So the status will be joined. And also, yeah, this is most used, basically creating accounts within an organization. Just really few clicks. You just need to provide the name of the account and the email address, which will be used as root email for this account. And click, and you could get the new account. And just, additional accounts not cost you anything. So don't worry if you think, oh, organization will cost a lot. No, it's the same price exactly as one account. You're just creating some accounts. It's free service. Don't worry. All right. Let me show you how you can access organizations. Basically, when you log into your management account, the master account, as admin, for example, or a root user, you can just go click on your username, click organization, and you will see something like this. This is my organization, my own private accounts. You see, I have 4 accounts. So I have one accounts management account. Basically, this is a account where I attach my credit card. I created 2 accounts. You see the status is created within an organization. And also I had the one account, like old account, I decided to join. So this account will join my organization. I will manage all of these accounts from just one centralized place. So you see the status is joined. So this is how it looks like. And I don't have any organization units here. Yeah, it's optional. You can place, accounts into organization. Basically, it's kind of folders. And why you will need this organization units, yeah, you will know in a few minutes. This is AWS organization hierarchy example, like really enterprise level, which is can be just real. You can use it, just as example. So you have your management account, you enable organization. I created here. You see 5 organization units. Sorry, here some typo. It's operational. Security, workload, and workload can be of 2 types, one for non-production, one for production. And I created, like we say, many additional accounts, all of the members accounts, and I placed them under organization units. So what is giving me really these organization units, that you can apply some policies into the organization level, organization unit level, and it will be applied to all accounts which belong to this organization unit. For example, if I apply some policy, which policy we'll talk in a bit. If I apply some policy to this organization unit, it will be applicable to all these 2, like basically everything what is going under. All right. Okay, so what is the benefits of using AWS organization? There's many of them. First, it's centralized management of multiple AWS accounts. You log into one account and you can manage all the rest of the accounts. Centralized consolidation billing, centralized billing. So you will have one bill for all of your accounts, and it will be split. You will see in my one of the last slides, as I told, Like you need to know how much cost production, and you need to know how much development cost. You will see it really nicely in the one bill. So resource and environment isolation. This is for security. A centralized way to manage IAM users. Basically, as best practices, you basically managing users, your IAM users only in management account, and you're not creating any resources in management account and master account. So, and you're giving permission to these IAM users to assume role, basically to switch to another account. For example, you will have, let's say, IAM group development. You will put whoever belongs to the development group into this group, and you will attach a permission to this IAM group that they will have access only to assume role to, let's say, development account, and they will have admin permission on this account. And they will never able to assume role to any other account, and they will not even have any access permission into the management account. They will have permission, assume role. That's all. This is only what they will have. So this is a centralized way to manage IAM users across multiple accounts. And if, for example, somebody leaving the company, you just delete the user or just deactivate it, and just that's all. Access to all of the accounts, whatever he had, is gone. Resource usage consolidation for usage billing, for usage discount. So as you know, maybe you don't know, if you're using S3 bucket, you're paying per gigabyte or per terabyte. But if you're using more, let's say, than 10 terabyte of data in S3, so you're paying a little bit less for each of gigabytes, something like that. Basically, you're having discount. So in the organization, AWS Organization, it's working the same way. Basically, you place your S3 object in S3 bucket in every account, doesn't matter. Everything is consolidated for the discounts. Reserved instances. So you can have account for just purchase reserved instances, basically to manage the reserved instance, and these reserved instances will be applicable to all of your accounts. So you for sure will not miss unused reserved instance. Sometimes people buying too much reserved instances in one account, and they running not a lot of the servers, and basically they paying for much because reserved instance you committed for 1 year, paying. So when you're using multiple accounts, you buy reserved instance in one, it's applicable to all of them, all of the accounts. Also, if you have AWS credits, if you go into some AWS event and AWS giving you some credits, you can apply it to your accounts. It doesn't matter to which account you apply, it will be applicable to all of them. So first, when you get the bill, AWS will use your credits if you have some credits, and after it will use your credit card as backup. Organization units, I told a few times about it. So the benefits placing accounts into organization units. So what it will giving you, you can use service control policy. By the way, service control policy or all of the policy you can use even without organization unit. But organization unit, this is one of the target to where you can attach this the policy. So service control policy, security boundaries on your AWS account. If you want to deny something on the account level, we'll have some example. What does it mean to deny something on account level or organization unit level or even on root level? So for example, your development users in dev account, the administrator, they can do everything in development account, but you want to limit this administrator access a little bit. They can do everything, but with some limitation. For example, you want to prevent them from using any other account than, let's say, Ireland. So you can apply a security policy to deny all of the rest of the accounts and use only one account. So even if the user's administrator, they will switch to any other account, they will see like API error or something like this, like no permission, even if they administrator. So it's like above the administrator, it's on the level, account level. And if you apply this policy on the organization unit, it will be applicable to all accounts under. If you apply it to root level, it will be applicable to all of the accounts, all of them completely, except of the management. And management, it's not applicable. So this is good to use organizations, giving you control of the accounts. You can apply some policies. Another policy is backup policy. It's centralized way to backup resources. We'll have slide about it a little bit more. And also there is another policy is tag policy, which you can apply also on account level, organization unit, or most cases it's root level. It's centralized way to manage and enforce tagging standards and tagging compliance. Okay, backup policy. So for example, you have your plan is backup your EC2 instances or RDS instances. and just some other resources, with specific, schedules. For example, you will have tiers, platinum resources, gold resources, silver and bronze. And just for platinum, you see, just have many retentions, many plans. So, and you have many accounts. So you need to create many AWS, there is a service AWS backup if you don't know. So you need to go there like in each account and create plans for each one of them. It's possible, but you can use it in centralized way. Basically, in the organization, you're creating policy for the AWS backup. Basically, here I'm creating policy. In this policy, you specify to which resources it will be applicable, which schedule it will be run, and automatically you attach this policy to a specific account in your organization, or to specific organization unit, or to on root level. And what will happen automatically, it will create if you will switch to any of the accounts, you will see in the service AWS backup, if you will go to the backup plan, you will see these plans automatically created. It's created on the organization by organization backup policies. And for example, my plans, how I start my backup, just adding some simple tags. So I'm just filtering resources by tag. And for example, I will if I will add tag backup tier and just one of these values, it will apply this backup plan. So AWS backup, if you don't know, it's really great service. Good to learn. All right, service control policy. We back to our organization and I'll show you. And service control policy, I want to limit some security stuff. And for example, I'm creating a service control policy called deny, and I want to deny start using any EC2 instances which is not equal T3 micro. Basically, I want to allow only run T3 micro. That's all. No T3 small, no T3 nano, no T3 large for sure. Not any like C5 or like any other expensive servers. Only T3 micro. So I can create this service policy and attach it to, for example, organization unit. What does it mean? These guys, whoever is here, like have access to these accounts, even if they admin, they will not able to launch any EC2 instance which is not equal to T3 micro. They will get a permission error. Another security policy is service control policy. For example, I want to apply to the security account, and it's just saying deny start any EC2, deny start any RDS. Like, I don't need to run here any resources. It's just security logs and security servers. No any servers should run here. No any RDS databases. So you can apply it specifically to one account. And for example, another service control policy which I want to apply to development account only. So my developers will able to use only T3 micros EC2 instances, not T2, not C5, not R5, not like any other. So only T3, basically only some basic stuff. That's all. So just and if even again the developer is administrator in the account, he can do everything. But because I applied service control policy, it's above him. So he will get access denied. And sometimes, by the way, it's freaking out people. Just I'm developer, and why I'm just how it's possible I'm getting access denied, and basically developer don't know there is a service control policy above on the account. It happens many times, by the way. Okay, tagging policy is a totally centralized way to manage and enforce. You cannot enforce, you can just manage. By the way, there's two standards, tagging standards. For example, you have tags which you want to apply to all of your resources called environment, env. And what the value of this tag? Value can be prod, maybe lowercase, can be production, production lowercase, many different values, and basically it's the same, but you want to make some standards. So you can create a organization tagging policy. With tagging policy, you can enforce again and cannot enforce a use of specific values. Case sensitive again. So if you enforce these tagging policies, no one can assign incorrect or not allowed tag value. They will get the error. I will show you how the error looks like. But if you not enforce, basically you just creating the standards, you can run. So everyone can create any tags, but you can get list of the get report, which resources have compliance tags and non-compliance tags. So you can get nice report for it. And here's the example. Here, this is my tagging policy. As you see, it's JSON, like simple JSON. So my tagging policy is for environment tag, and the values which I allow, it's dev, you say lowercase, and I enforce it for EC2 instances. So only for the EC2 instances, these tags will be enforced. That means no one will be able to add different values. For example, here you see I have EC2 instance called my server, and I try to add tag environment prod, like, just it's not allowed. Allowed only prod and only dev. So you will trying to say the tag policy does not allow a specific value for the following tag. By the way, it's not showing what is allowed. By the way, yeah. So there's the corporation should have some documentation, with standard tagging. So whoever is creating resources need to know these standards to apply, because here he will not see what is allowed. And lastly, organization bill, how the organization bill will looks like, and how you can see how much dev cost you, how much production cost you, how much any other accounts environment cost you. So your bill, if you will go to the AWS billing and click with the bills, you will see charges by account. You can see the charges like total, and you can click on the charges by account, show you all of your accounts and how much each one of them cost. You can click like plus, and see specific services, how much each service costs. So you just can analyze. But it's really nice, this is a great way to see how much, for example, development, stuff cost you. And that's it, I think. Thank you. If there's any questions, guys.
Yes, thanks a lot, Dennis. Thanks a lot for such detailed presentation. And we have a couple of questions for you. And let me show it for our audience. And the first question from Ruben. Do you have experience is merging to AWS Organization? And what is the best practice for this? Are there any automation to transfer accounts, resources between organizations?
No, I don't have unfortunate experience with merging two organizations. If I think just merging organizations, basically joining like leaving organization in one account, in one organization, leaving. So accounts leaving organization, because account can leave organization. If you will apply the credit card and put all the details for the member account, this account can leave organization. By the way, you can prevent account from leaving organization by applying a service control policy. This is what usually we're doing on the work. So no, I didn't experience such a things. But regarding a automation way to share or transfer resources, you can share resources between accounts. Some resources can be shared, like for example snapshots. You can you have servers, you're creating snapshots, you're sharing it with another account, just creating EC2 instance or RDS instance from this snapshot. And basically it's kind of way of sharing, of moving resources. It's like, I don't know, it's kind of lift and shift, I can say, just basically backing up and just restoring. But this is what I have. In my experience, we never did it like leaving one organization and joining the new one. Don't remember in my experience.
Thanks for this answer. And the next question from Oleg. Oleg, can tag policy affect on also created resources?
The answer is no. If you have your policies created like today, but your accounts already exist like few months, there are many resources running, it will not affect any existing resources. But so you will think, okay, how I can correct all the incorrect probably tags? You need to run this report, and it will show you what is compliant and what is not compliant. Compliant is what is written in your policy, what you set up. But what is not compliant is, for example, somebody called it production, and you decide that your standard will be prod, environment will be prod. So you can get list of the incorrect, non-compliant tags, and just need to make the changes. Give tasks to one of your DevOps cloud engineers. Okay, apply the standards. So the next time I run the report, it will show everything is compliant.
Okay, next question from Alexander. How could we set service control policy to root user? Root user almighty, does it mean that he could do anything?
You cannot set control policy to root user on the management account, but you can, what you can do, you can create service control policy to not use not execute any API action of your root users of the members account. Basically, you can limit use of root user in the member account. So even the root user will not able to log in, just completely disable this user. But on the management account, there's nothing you can do. Root users can do everything. It's admin. If you will lose control of your management account, basically you're losing control of the whole organization. So this is why service control policies not affecting management account, and for sure they're not affecting root user in the management account. But as I told, you can limit use of root users in your. You cannot affect your management account, your root user, but you can affect root users in the members account. Usually we're not using a root user at all, so just limit it completely. And by the way, when you're creating your member account, additional member account, in order to log in as root user, you need, you don't have password, by the way. You have username, it's your email address which you use to open this account, but you don't have password. You need to go and reset your password, kind of just basically go to the login page of the root users, and it will send the email with a reset link to reset your password. And if you didn't have any password, we usually limiting the use of the root user completely by using service control policy. So even if you will reset the password, you will not able to log in with root users to any of the members account. Because if you log in as root user to member account, that means you can leave the organization. Basically, you can just set up your credit card, address, all this stuff, and basically go to the organization, leave the organization. And again, if service control policy will not prevent you to leaving the organization.
Thank you, Denis, for your answer. And the last question from Sergey. Do you recommend to use landing zone as a starting point for messing with organizations?
Yeah, landing zone, basically control tower, can simplify the way to create multiple accounts. But when I reviewed the control tower, it's I can compare it with what is EC2 instance, and what is light sail. AWS light sail service. It's kind of simplified way to use EC2 instances. So if you don't know, AWS service and afraid to use them, so you can use a light sail to launch simple VM. So the control tower landing zone, basically it's the same as light sail. I think if you don't know deeply services on AWS, so maybe better to use or afraid just use cloud control tower's landing zone. So it will provision you multiple accounts, like few accounts. You can create more accounts. It create this cloud trail for you. It will deploy the AWS config for you automatically in automation way. It's like kind of simple step. But what we're doing, for example, in the company, we have our own Terraform code, to provision landing zone, which which using all the best practice, and you have full control of it. On the control tower landing zone, I think you kind of losing a little bit control of some stuff. It's provisioning so many resources, and you're not sure you really need all of them. But it's if you decide to use organization, create multiple accounts, and control tower, it's only if you're afraid really to create accounts yourself and deploy cloud trail yourself on the organization level, and you're afraid or don't know how to deploy AWS config on the organization level. So use control tower for it.
Okay, thanks a lot, Denis, for all of your effort during today's event, and thanks a lot for your time, and hope to see you next time in our event. But by the way, guys, Denis will stay with us till the end of the event. If you have any question, feel free to paste in our chat. And let me pass the floor to our last speaker, but not least for today, Pawel Piwosz, AWS Community Builder, DevOps Institute Ambassador, owner of Last Week in IT Podcasts, CD.Foundation Ambassador, who also successfully lead Epam Cloud Academy. I want to thank you for your time and effort in teaching and supporting newcomers. You are making real difference, and I'm happy to work together with people like you.
Thank you.
Very welcome, Pawel, and floor is yours.
Thank you very much. So I hope you are still here. So let's jump to another kind of security topic. So today we have three topics related somehow to security, because even chaos engineering is related to security, to the business security, right? Okay, so let's get started. I'm sorry, not this one. Okay, go away. Just give me a second. I need to find proper window here. Yep. All right. So let's talk about security or security checks or the quality checks even for the infrastructure as code, right? So what it is, what it is really needed to us, for us. So first of all, we need to think about one very specific situation, because DevOps and security really not go together, right? So we have two words that DevOps will say that security slows us down, but and this is the real quote from my friend: "I hate DevOps. You don't care about security." And you know what? It's true. Both of them are true, right? So we have DevSecOps, but still, let's be honest, it doesn't work that well as it's supposed to do. And before I start to go deeper, this is kind of breaking news. This is something what I received today on my email. So from the Aquasec blog, you can find our newest article about the misconfigurations in cloud. So 250 millions of artifacts were exposed, and 64,000 containers images were exposed by companies. And many of those companies are like, maybe not majority, but many of the companies from the Forbes 500. So yeah, security is important, right? Because probably they don't want to expose these things. So my name is Piwosz, and as you already mentioned, Anton, I'm CD.Foundation ambassador, DevOps Institute ambassador, and AWS community builder. And I've been working for Epam for 4 years right now as a lead system engineer. And my question to you is, what is infrastructure as code? Normally, I'm waiting for the responses from the audience, but let's skip it and just go to the definition, right? So what is infrastructure as code? Well, it's fast, dynamic, programmable way to deploy hidden infrastructures misconfigurations everywhere. To prove it somehow, we can talk about some breaches related to this, and just the previous slide showed that 200 millions of 200 millions of artifacts were exposed because of the misconfigurations, and many of those artifact storages were created using infrastructure as code, right? And in last year, maybe you remember like epic breaches from Uber, Revolut, Rockstar Games, and Samsung. And Samsung came back this year with ChatGPT, right? So let's take on some numbers. And those numbers are reasonably fresh because it's this data is taken from the Ponemon and IBM and Ponemon Institute report from the last year. And what is the average cost of the breach, data breach? How do you think? 3 to 1, the answer is more than $4 million, right? For each breach. And of course, the same addition here, like Victor did on the beginning. This is not something what you can apply to each companies, right? This is something what you can apply to the companies who answer to the survey from IBM and Ponemon Institute. The industry with highest cost of the breach is, of course, healthcare, right? 10 millions. Well, that's quite a sum. I would like to have that kind of sum. Average cost per record in breach is $164. So this is how much you cost during the breaches, right? So that's our price, let's say. And this is interesting. What is the average time to identity and contain the breaches. What is the difference? Identity, that I realized, oh, I was breached. And then contain means that the time which is needed for my organization to contain, to fix, to close this gap, right? So it's 277 days, where 207 days is the time to identity and 70 to contain. What it means? That after almost 1 year, you realize that someone is just dancing into your application, and then you need 2 months plus to fix it, right? So that is the number which should put some thoughts to our minds, right? But let's go to the cloud. What is the percent of the cloud-based breaches? Because this is the topic which we are interested in most right now, right? So it's 45%. And in that, 50% of breaches is because cloud misconfigurations, right? And many of these breaches is done because there is no infrastructure as code. And yeah, that's another problem. But some of those are also done because the infrastructure as code is written maybe, yeah, I would use this word improperly, right? And average cost of breach caused by this misconfiguration is 4 million, right? So this is a lot. And what kind of cloud misconfiguration, or what kind of like an example of the issue I can show you. So this is according to the State of DevSecOps by Accurix from some time ago. This is kind of old thing, but it shows the picture. So Imperva in 2019, the breach was like a focused on the customer records, like API keys, TLS certificates. Why? Because the network misconfiguration, because the hard-coded API keys and not encrypted records in database, right? And how long it took them to fix this? 10 months, right? So imagine now, for the 10 months, someone has access to your API keys, to your TLS certificates, etc., 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 right? So you can do everything what you want to be secure, safe, and on the bright side of the force, but then this happened, right? And here we talk about two elements: cloud misconfigurations and also configuration drifts. I don't want to touch configuration drifts in this talk because this is completely different topic, huge topic, right? So let's focus on the cloud misconfigurations. So what we can do before we deploy, right? Our infrastructure. Configuration drifts is what we can do and what is going on after we deploy. Excuse me. So the fact is that 90% of organizations allows user to make changes without proper process. In other words, I have an account in AWS account. I'm going there and just click in the console like drunken monkey doing things, right? Changing security groups, creating new ones, open accesses, create RDS with public access, etc., etc., etc. Another fact is that 43% of the organization didn't start or is just starting any approach to the infrastructure security, right? And this is really new data. It's again, according to IBM report from last year. This is unbelievable, but it's true, right? So now let's go to the more interesting topic: types of misconfiguration. Honestly speaking, if you work a little bit with clouds, you can assume that, right? So the biggest percent of the misconfiguration is related to AAMs, to security groups, to encryptions, right? And to abandoned resources as well. Why this is important? Because abandoned resource is exactly what it is: abandoned resource, not patched, not managed. Everything is possible with that. Probably it is very old system, very without any proper patching, etc., etc., etc. This is the potential risk in your world. How organizations capture the issues, right? 33% do it by manual checks before deployment. Well, at least they check. And 27% do this as a post-deployment check, right? So is there anything what we can do with that? Because it sounds not right? At least for me. Maybe for you it's okay, but we can discuss this later. So what we can do? So first of all, we can have a process which includes infrastructure as code. Process which includes hardened access for user. So no access to environment, just to manipulate things, right? You do everything through infrastructure as code. And generally no manual integration into infrastructure, right? So everything needs to go through the codified approach. And going back again to this conflict between security and DevOps. DevOps today, the DevOps cloud engineering, right, is very fast. We do things quickly. Victor can tell you how many deployments per day they do in AWS. It's very quick, right? But security is slow. So what we need to do is to help a little bit the security, right? To speed them up. And together with this, please remember that if you find any misconfiguration in a deployed infrastructure, it's already too late, right? Because believe me, there are people out there who are able to catch your misconfiguration very quickly in terms of minutes, right? If you want to do an experiment, please create DC2 machine, open the security group for SSH to the whole world, and log back in half an hour, and you will see very interesting log after that half an hour. So just to prove my thesis here. So what we need to do is to control before deployment. How we can do it? By using dedicated tool. And by using this dedicated tool, we prevent deployments of misconfigured templates the best way through the CI/CD pipelines, right? And this helps us because the pipeline can fail and prevent the real deployment. And we have a lot of tools around. So just to give you a couple of examples, Chekhov, Terrascan, TFSec, CFNNAG, Snake. So those are the free tools really to use. And with the demo, which I have in a minute, I will compare free tools. Chekhov by Bridgecrew, Terrascan by Accurix, or Tenable right now for like 2 years or something, and TFSec by Aqua. So all of these free tools are really, really powerful. Obviously, Terrascan and TFSec works for Terraform. Chekhov works for Terraform, CloudFormation, IRM, many others, right? For hand charts, for Docker images, for GitHub Actions. So quite powerful tool. And how easy we can implement it, because very often we can hear the sentence, the implementation of that kind of tool will take time. Yeah, this line here, this is what you need, right? Just that. It's one line, right? 2 lines if you want to install this tool as well, right? Okay, so enough talking, more or less. And now let's see what we can do. So what I will do is, as probably we have limited time, I will jump into GitHub and I will show you some interesting part. So first of all, we have GitHub action pipeline here. I have 3 jobs here. One is for running Chekhov, and as you can see, I'm set up the Python, and just this is not really necessary, and then just I run the action from Bridgecrew with Chekhov, right? And I'm checking everything what is in this directory. Second scan is Terrascan, which runs the Terrascan also using the action delivered by Tenable, right? And I can even limit the version of the Terraform, what the policies I will use, etc., etc. And therefore, final one, TFSec, I'm also executing the Aqua Security TFSec action, and that's it. Of course, all of them can be configured more to your needs. All of them can create reports, etc., etc. But in fact, when you run this pipeline, you can see, oh, I will do something else. I will show you the second pipeline, which is a little bit more complicated. This is the pipeline for pull request. What I'm doing here, I'm using a Chekhov as well, and also different scans. So Chekhov is here with the publishing the artifact. We will see it. And also I have the second job, which generates some checks from Terraform, right? So I have Terraform format check, because why not? I have Terraform validate, and I have Terraform plan. So what we will do now, we will jump into the code to the main branch. Let me just update it, just to be sure that I have everything. All right. So what we will do, we will just do very small change in the code. For example, even in README, that doesn't make any difference right now, because I prepared this in that way that every single change will trigger the pipelines, right? What I should do is maybe previous first step should be create new branch. I will call the test. So let me just save this, or I will just remove the. No, let me just save it and commit with whatever. Yeah, the best description of the commit. That's something what is great. And let's create the branch again. No, thank you. Right, yes, of course. Okay, so let me just do the branch like this. And I'm on this branch, and what I will do is just add some text here, save, and just publish new branch. Okay, I should have this branch soon in my repository. Yes, so I have new branch, and when we go to the actions, nothing happened at this point. That's fine. So let me just create pull request. I finished my work. I'm okay with my changes. Let's create the pull request. And for now, the first action took place, right? So this is the action for pull requests. So this is like a sanity check if this is, valid to be considered to merge to master at all, to main at all, right? And here we have two actions. Let's see them. Of course, this will fail because I leave the template in that state that I have misconfigurations, right? And as you can see, first check already failed. And I have a lot of information here, right? With even with the information about the specific file, with which line, what is the error, what is the guideline to fix it, etc., etc., etc. So everything is here. For example, here you have the ID of the issue, the title of the issue. So everything is here, right? And Terraform plan, of course, went well, because from this perspective, everything is fine. So let's see what we have in pull request. So first of all, pull request failed, right? So we see that. And we have very nice information about all states. So really nothing escapes us. Every change is here. So those can be tested. And we have output from the from Chekhov in this case, right? So we did 66 tests, from which 18 failed, right? And we can go and check all of them. For example, this one, ensure S3 bucket object is encrypted by KMS, right? And I can go to specific block, see that, fix that. So this is how it works, right? So let's suppose that this pull request is fine. And I can merge it. So I'll merge it. Confirm merge. And now when I merge this pull request into main, another pipeline started, right? The pipeline which I called like a main pipeline, right? So this is executed on main branch because previous one, this pull request, was executed on the pull request to the main branch, right? So what's going on here? All three scanners are executed here. So let's go and check one by one what's going on there. So this is Chekhov. So I install Chekhov, etc., and then I run the test. So this is the way how Chekhov will work in your CLI when you use it in CLI, right? So simple like that. So you have all information about the idea of the issue, about the what issue really is. In this case, this is past, so just the information, right? So here below we have errors, right? So we have error in this file in lines between 1 and 10. This is the guide what we should fix. This is the ID of the policy which is not compliant here, and this is this KMS key, right? So we have this, and on the end of this report we have the information. We should have information somewhere. As you can see, this is also for GitHub Actions. So I need to find. Probably I will be not able to find it, this long file. But you will remember, it was 66 issues for Terraform, right? So it should be somewhere here. No, something like that. This is for Chekhov. Okay, for GitHub Actions. All right, but 66. It was 66. And let's keep this number in mind. So Terrascan has some similar information. So you see that we have the description of the policy which we do not follow, in which file, in what module, which line, and even the severity, right? There is no description what we should do with that. So Terrascan do not provide that. And again, like with previous check with Chekhov, we failed the pipeline. And the final one is the TFSec. Again, we have the information here, just quite nice summary of the execution with the information how many tests were done and how many problems were checked, right, or were found. So quite interesting. And again, it failed, right? So all three checks failed our pipeline. So quality gate, job well done, right? And now you can ask why those three scanners shows different number of issues. And this is the biggest pain here, because all of them do things in different ways. They have different I'm sorry, let me just jump back to the console, or maybe I will do another console, another show for you, just to give you the example on AWS because, well, we are in the AWS meetup, right? So let me just do this. Right. So we have here the code pipeline. And I've got the pipeline. Come on. Yep. Which looks quite similar with Chekhov, TFSec, and Terrascan. And, all of them can beautifully create the reports, which we can check with all information about the problematic scans, right? So everything is there. All three of them shows that. So from this perspective, it looks really, really nice and easy to implement. Really easy to implement. This is something what we need to remember. This is really easy to implement. Right. So I think that's enough for the presentation. Please remember that if you pretend that you have security, it will be exploited, right? So implementing those scanners with Chekhov, Terrascan, TFSec doesn't matter. Anything else is not that time consuming. Fixing the stuff will be time consuming. Yes, that's for sure. But believe me, it will be less problematic than fixing the reputation of the company, etc., etc., etc. Right? So yep, that's it for from my side. If you like to connect with me, those are the links and link to our podcast, which honestly speaking has the premiere today. So yeah, that's the thing. So
Yes, thank you, Pawel. And I'm already enjoyed your new podcast, and I highly recommend to everyone just try
thank you.
and listen. Yeah,
It's different.
Thanks a lot.
It's different.
Yeah, we have a couple more time, guys. If you have any questions, feel free to ask in our chat. If someone want to add something, maybe Victor, maybe Dennis, feel free also. If no, let's just wait a couple more minutes and probably we can close our event for today.
Looks like no questions to my topic. Like it was also too obvious, or already
Not yet,
everyone
I would say.
implemented in the security. So that will be surprising.
I would say from my side, it was really, really interesting, and I hope the audience also enjoyed. Maybe Victor is able to join to us, and Dennis, and maybe. Oh, welcome back, guys.
Hello, hello.
Yeah. Probably we don't have any questions, and maybe we just can close our event. I see. Thank you, DevOps Stars and Denton, to organize this such brilliant meeting. Thank a lot, guys. If you have any feedbacks, feel free to paste in our chat. You are very welcome, guys. And yeah, probably in closing, I want to thank you again, guys. I want to thank our amazing speaker Victor, Dennis, and Pawel for sharing their knowledge and experiences with us today. You are all inspiration and role models in the AWS community. And I want to thank all of the attendees for being here today, asking great questions and participating enthusiastically in the discussions. Event like don't happen without people like you. And I want to thank you all of my mates which helped me with organization of this event. And yeah, I hope next time we will be able to organize offline meetup, and I will be able to invite all of you guys, and you will be visit Gdańsk. And yeah, and I see we have one more question. I hope this the simplicity of the sec tool will be catch for more new joiners and the older ones. Okay, thank you for your feedback.
Yep, hopefully, yeah. Because this is really
guys.
easy. There is no excuse to not use it. Sorry.
No, that's fine. I mean, thanks a lot, guys, for all of your effort during today's event, and I believe we can close it. Thanks a lot, and see you next time. Bye bye.
Thank you, guys.
Have a nice time.
Bye bye.